Okay. Diodes then. We're adding a few more components into our small armory of electrical components, and diodes are resistors that only function in one direction, essentially. Let's see what it says in the red box. Circuit components which have a very high resistance in one direction and a very low resistance in the opposite direction. Very good. So regular diodes are indicated by this arrow hitting a wall, essentially. Yeah. And the arrow points in the direction which they will allow current to flow in, i.e. the direction in which they have a low resistance. Light emitting diodes are famous because they're used in most modern lighting now because they're very, very efficient, energy efficient. In fact, a mate of mine from university did his PhD with the man who invented them. So he's a very rich man now. And it is the diodes that emit light with high efficiency, which is a bit strange because diodes, their primary purpose has nothing to do with, they're not designed to particularly emit energy. It's a sort of happy byproduct of light emitting diodes. Right, so the way diodes work, we've got this circuit, both circuits, the current is going counterclockwise. If I put the diode this way, well, that's fine. It's got low resistance, so high current can flow. Lovely. But if I put it the other way around, it's got very high resistance, prohibitively high resistance normally. And so actually you get hardly a trickle of current flowing through at all. Okie dokie. How is it best to plot this? Which way round do we want to do it? Yeah, let's go for this way. If the current is, no, sorry. I see. We've pre-planned it such that the right side of this graph represents the situation where the current is aligned with the arrow of the diode. Fab. So in this case, you get very high, very low resistance, which remember on an IV graph means that it's very steep. Steep is good. Steep is good. Shallow is bad. Cool. So very low resistance. And in the opposite direction, it's the shallowest you can possibly get. It's basically flat. So it's very, very, very high resistance. In other words, looking at this graph, you're applying this energy per unit charge. You are, people often use an analogy between circuits and water pipes. The water pump is whirring as fast as it can go, and yet the water's still not really going anywhere because there's such a small change in efficiency. Sorry, I'm going to slightly edit my diagram because this should technically still be negative. We're running it to the right. We are operating our water pump, our cell, pumping the electrons one way. To the left, we're just running the pump in reverse. So it would technically be more accurate if we'd reversed the direction of the cells rather than the diodes, but whatever. Anyway, you keep running it very high. The current's not going anywhere until eventually the flood barriers do break. You do reach a breakdown voltage. Your poor diode is doing its darn best to stem the tide. It suddenly reaches its breakdown voltage. I've got a note here saying that is not in the OCR specification, but it's good to know anyway.